So guys, your first vocabulary word for today is adjacent angles. Adjacent angles are two coplanar angles with a common side and a common vertex. So they're adjacent to each other. They have no common interior points. So for example, I have angle 1 here and angle 2 is adjacent to it because they share a side, but they don't have any points in common. Okay? So it's two angles that are shoved up right next to each other. The other type of angle, and mine is kind of, there we go, that you are going to see are called vertical angles. Vertical angles are two angles whose sides are opposite rays. So, for example, in this drawing, angle 1 and angle 3 are vertical angles because they're vertical from each other. They have opposite rays as their sides. And angle 2 and angle 4 are called vertical angles because they have opposite rays as their sides. So it's angles that are diagonal from each other. But they have to have opposite rays. Yes. Complementary angles are two angles whose measures have a sum of 90. Each angle is called the complement of each other. So in this one, I actually give you the measures. So CAD is 47 degrees, and BAC is 43 degrees, and that adds up to 90. So we can say that they are complementary to each other. Another way we know if two angles are complementary are if I give you the little symbol in between them, but no measures. So if I tell you that the whole angle is 90 degrees and then there's another ray going through it, you can also tell that the two are complementary. Does that make sense? Like I'm not always going to give you the measures and you have to add them up. Sometimes, and you'll see what I mean in just a second, sometimes I will tell you that the whole thing is 90 with no measures at all. So we have complementary angles and then we also have supplementary angles. Supplementary angles are two angles whose measures have a sum of 180. So each angle is called the supplement of the other. So basically when you put them together, it forms a straight angle or a straight line. So in this case, we know that they're supplementary because I can see that the base is a straight angle and then there's a ray going through it. So angle 3 and angle 4 are supplementary. So sometimes you'll have to determine if they're complementary or supplementary based on angle measures. And sometimes you can determine it based on the way that the picture is drawn. Okay, guys, so we have two more vocab, so it's going to be on the other side, so you'll probably have to draw the grid. The next one is a linear pair. So a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So in this drawing, the non-common sides, meaning BA and ray BC. A linear pair forms a straight angle. Okay, so it's actually very, very similar to supplementary angles. So we would call these two are supplementary as well because they add up to 180. But they are also called linear pairs. Okay, so it's the exact same thing. An angle bisector is a ray that divides an angle into two congruent angles. So, for example, an angle XAZ, ray AY is an angle bisector, so we can indicate that those angles are congruent using the little arches. Okay, so it's the same as a segment bisector, but with an angle. So 7.5, we're starting with an example. So I give you this figure, just do the best you can, and we're going to draw a couple conclusions from it. Okay? So we have one conclusion that we can make right off the bat. We're going to list the vertical angles, we're going to list the adjacent angles, and we're going to list the adjacent supplementary angles. So I have this figure here, and there's 5 angles. Now, the first conclusion that we can draw should be pretty apparent. When you guys looked at this, what was the first thing that you noticed about it? There's a bisector. Diego, where?
Oh, between 2 and 1.
Between 2 and 1. What do you notice with the markings? 2 and 1 are what? It's not 90 degrees. You can't assume they're 90 degrees, but it is congruent. So we can say angle 1 is congruent to angle 2. And in parentheses, I'm just going to write by markings. Because we can tell from the given or from the markings that are already on the figure that those are congruent. Does that make sense? Yeah. So usually whenever I get a geometry problem and we're talking about angles and pairs, I first always mark all of the congruent stuff that we already know. Now in this unit so far, it will be given to you, okay? But we'll in the next unit start learning stuff about angles where you'll be able to determine which ones are congruent and which ones are not, based on some rules, okay? Yes? Okay, vertical angles. So you might need to go back to your definition of vertical angles. There are two of them, or one pair of vertical angles. What are they, Jason? Angle 3 and angle 5. Okay, so angle 3 and angle 5 are vertical angles. We cannot say anything else is vertical because angle 1 and angle 2 are two separate ones. However, we're not going to write this, but let's just talk about it. If I took the measure of angle 1 and added it to the measure of angle 2, then would they be vertical to angle 4? Yeah, okay? But we can't say that right now. So right now, the only vertical ones that we know are angle 3 and angle 5. Adjacent angles. There are 1, 2, 3, 4, 5 pairs of adjacent angles. See if you can figure out what they are. So adjacent just means that they're right next to each other. So our adjacent angles are going to be 1 and 2, angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 5, and angle 5 and angle 1. So I also want to know which angles are adjacent and supplementary, which means they add up to what? 180. What does supplementary mean? 180. 180. And I want them to be adjacent, meaning I want them to be next to each other. Because technically, two angles could be supplementary if they're not next to each other, as long as they add up to 180. Yeah, but adjacent supplementary means I want them to be next to each other. So Tyree.
3 and 4.
3 and 4. Do you guys agree? 3 and 4?
Yeah.
Yep. Angle 3 and angle 4. Oops, angle 4. And then, what else? Delilah. Angle 4 and angle 5. And that's it. Actually, I'm going to put in here how we know that. The measure of angle 3 plus the measure of angle 4 should come out to what, guys? 180. 180. And the same thing with 4 and 5. So the measure of angle 4 and the measure of angle 5 comes out to 180. Okay? Not too bad? Okay, so there will be some problems on your homework, on your practice, where I give you a figure, and then I will give you some statements, and you have to tell me if those statements are true or false, based on the definitions you know. So that's why I'm having you guys write all of these definitions, because a lot of geometry is being able to make conclusions or justify your reasoning or make statements solely based on definition. So are these supplementary? Yes, they are, because they add up to 180. So that would be a true statement. Okay, so a lot of geometry is based on this. So you have to make sure you have all your vocabulary. You have to make sure that you practice it. Okay, we will be practicing in class a little bit before the test. Okay? Okay, so last postulate of the unit, 9.
Yeah.
So postulate 9, if two angles form a linear pair, then they are supplementary. So if two angles make a linear pair, meaning they have two opposite rays as their bases, that means that they form a straight angle, which is 180, which means they are supplementary. Okay, so that's just a postulate. So, for example 2, I give you angle ADB and angle BDC, and I tell you they are a linear pair. So let's draw the picture first. A linear pair means that their bases are opposite rays. So we're going to start by drawing a straight angle. Now, 3x plus 14, 5x minus 2. It doesn't matter really if it's to scale, so why don't we go the opposite way this time? So we know they're going to form a linear pair. And it says ADB, so D is the vertex. Let's put A here and B here. And BDC, so BD and then C has to be here. Does that make sense, guys? How to draw it? Now, if it turns out, once we find the measures, that angle BDC is actually supposed to be bigger than ADB, do you think that really matters? No. Not really, because we don't know what the measures are. So we're just making an educated guess to help us visualize what's going on, okay? So if your picture doesn't necessarily match what's going on, chill, it's okay, okay? Or you can change where the points are if it really bothers you, okay? So measure of angle ADB is 3x plus 14. So ADB we know is 3x plus 14, so I'm going to just write that in the angle just to help me visualize. And then I tell you that BDC is 5x minus 2, so I'm going to write that. And I want to find the measure of each one. What other information can I use? They all equal 180 when I do what to them? When I add them. So let's add them. 3x plus 14 plus 5x minus 2 equals 180. So we can assume that based off of the definition of linear pairs. Okay, so that's what I was talking about, that you're going to use your definitions to be able to solve problems. So I don't tell you that they add up to 180, but you can assume it because I tell you that it's a linear pair. Okay? Okay, go ahead and solve this at least for x for me. Diego, what did you do first?
Okay, so first I combine like terms.
Combine like terms. So 3x plus 5x gives me?
8x.
8x. And 14 minus 2?
Got me 12.
Plus 12 equals 180.
And then I reversed it.
What'd you reverse?
I minus 12 from both sides.
Subtract 12 from both sides. So we get 8x equals?
168.
168. And then when we divide by 8, we get x equals what?
21.
21. Okay. Are we done?
No.
No. What else do we have to do?
Plug it in.
Plug it all back in. So we plug in x to each one. So find the measures for me.
One man.
Tim, what did you get for angle ADB? 77. Agree, disagree? 77 what?
Degree.
And then, come on, what did you get for BDC? Still working? Okay. 103. So Delilah just gave us a good, okay, so Delilah gave us a really good solution for checking that our answer is correct. 77 plus 103 should come out to what?
180.
If it doesn't, something went wrong, okay? Then Tyree pointed out that we got that ADB is 77, but the way we drew it was obtuse, and BDC is 103, but the way we drew it was acute. Like I said, does it really make that big of a difference? No, because I did not ask you to draw the picture based off of this information. We drew the picture just to help us see what was going on. Okay? So if I gave you these angles and then I asked you to draw the picture, then I would expect it to be accurate. If not, if you are just using the picture to help you visualize it, it's okay. Okay? If it bothers you that much, you can change the name of the point. Okay? Okay, so example 3, I give you a picture. I give you angle FGI, and then ray GH goes between them, and I tell you that ray GH bisects angle FGI. So what can we assume about those two angles?
They're equal.
They are equal, and I also gave you that, where I put the two arches on there to indicate that they are congruent, okay? So we want to find the measure of angle FGH. Okay. Tori said what we can do is set them equal to each other because we know that the bisector makes the angles equal. Solve for x, and then plug it back in. Do that right now. So our plan was to set them equal to each other. So 3x minus 3 equals 4x minus 14. Hopefully, your next step was to subtract 3x, right? And then is everybody okay if I add 14 in the same step?
No.
No?
Yeah. I'm gonna try. Oh, here we go.
Okay. Negative 3 plus 14 gives me 11, and 4x minus 3x gives me 1x. Now, I solved for x. Am I done?
No.
Heck no. We are looking for FGH. So we plug it back in. So the measure of angle FGH is equal to 3 times 11 minus 3, which is 33, minus 3, which is 30. That's your answer. What if I asked you to find angle HGI?
Same thing.
It's also what? 30, because they're congruent.
Yes, they are.
Okay? Okay, so on the left side, there's only 2 questions.
Oh, okay.
Angle ABC and angle CBD are complementary. So that's, you have to look the definition up again. If the measure of ABC is 2x minus 10 and the measure of CBD is equal to 3x plus 45, find the measure of each one. So you probably want to draw a picture. And then number 2, I'll move it again. Hold on. Number 2, I give you this figure. Hold on. And then I give you 5 statements, and I want you to just tell me if those statements are true or false. Now, I want to explain one thing about the picture, and then I'll put number 1 back up so you can finish writing, okay? On the picture, it is showing that angle 1 and angle 4 are what? Congruent. Now, here's what I want you to be aware of. Angle 5 has just one arch, and then angle 2 and 3, that arch goes with both of them, okay? So that means that angle 2 and angle 3 together, not necessarily bisected, that these two together are congruent to angle 5. Okay, it's not one arch on each one, it's one arch for the whole thing. Okay?